Now for projectile motion, let's take a simple case where our body has been projected from ground with the velocity u, making angle theta with this axis or with the ground. Let's take it as x-axis and let's take it as y-axis. So the body goes from here to here. Let's elongate further. So let's say this body goes from here to here and finally reaches a point B and strikes the ground at point B. This is point A, this is point B, and we are interested in some of the basic concepts, that is, what is time of flight, that is, what is the time it is going to take to reach from here to here, and what is a maximum height, this is a maximum height, and what is the range, what is this distance, what we call as a range of this projectile. So we are interested in first time of flight, second is maximum height, and the third is range of this projectile when the body has been projected with the velocity u at angle theta with the x-axis in the upward direction. So over here we shall be making use of our earlier understood concepts of motion under gravity and how a vector is resolved along the x-axis and along the y-axis. So first thing what we do is we resolve this velocity which is stuck between the two axis, that is x and y axis. This velocity is neither purely along the x axis nor purely along the y axis. This vector is between the x axis and y axis. So our first thing is, let's break this velocity along the x axis and along y axis. What we are primarily doing is we are breaking this motion in two dimensions as motion along the x-axis, that is motion in one dimension, and motion on the y-axis, that is motion, the other motion in one dimension, and we are simplifying our case of motion in two dimensions as two individual motions but connected motions along the x-axis and along the y-axis, that is motion in one dimension cases. So for that we break this velocity, one is along the x-axis and the second component we find along the y-axis. From our earlier understanding of, that is, how we break a vector along the rectangular components, so this velocity vector can be broken in two components. This component comes out to be u cos theta, and the vertical initial velocity component, it comes out to be u sin theta. This velocity component along the x-axis is responsible for taking the body along the x-axis. If this component is not here, this body will simply go up and come down if this u cos theta is not there. Similarly, if this velocity component is not there, this body shall be just be moving along the x-axis only. Because both the components they are there, so that's why this body shall be moving along the x-axis also, and this body shall also be moving the y-axis also. So once we have dealt with this velocity vector, that is, we have broken this velocity in two components along the x-axis and along y-axis, let's go to acceleration vector. When the body is going from here to here, all the time Earth says, I'm going to pull you in the vertically downward direction, that is purely along the y-axis. Generally, many students they get confused, that is the direction of acceleration is same as direction of velocity. It may or it may not be the case. Like over here, when the body is going like this, its velocity is always tangent to its trajectory. Velocity is over here, velocity is over here, velocity is tangent to the path in this direction, velocity is tangent to the path in this direction. Whereas the acceleration vector is always vertically down. It is acceleration is always vertically down. That is, acceleration is g in the downward direction, acceleration is g in the downward direction, acceleration is g in the downward direction. Because once we have given this velocity, there is only one force which is acting on the body, that is the weight of the body. All the time the weight of the body is acting in the downward direction. That is the only force which is acting on the body. Had the g be not there, had the action due to gravity be not there, then this body, if you have projected this body on the surface of Earth in this direction, it would have gone in a straight line like this till infinity. If we neglect the effect of other planets or other stars onto this body, it is only because of Earth's pull that it goes like this in this path. It is only because of gravitational pull of Earth that this path it becomes a parabolic path. All the time Earth is only applying a force in the vertically downward direction, and that is equal to mg. And as we know, Newton's second law of motion, that is F is equal to ma, force is equal to mass into action. Whatsoever is the direction of resultant force, the same has to be a direction of net acceleration. all the time if mg is in this direction, so mg is equal to ma, so a is equal to g in the downward direction. Or we can say acceleration along y-axis is g in the downward direction, because there is a force which is acting this way. Force is equal to mass into action, and there is no component of this force along the x-axis. There is no force. If we say this is x-axis, this is y-axis, and if a person goes 10 meter along the x-axis, how much he has gone along the y-axis? He has gone 0 meter along the y-axis. Similarly, if a person has gone 5 meter purely along the y-axis in this direction, how much he has gone along the x-axis? He has gone 0 meter along the x-axis. Similarly over here, if we take it as y-axis and if we take it as x-axis, there is only one force which is acting purely on the y-axis in the downward direction. What is the component of this force along the x-axis? So there is no component of this force along the x-axis. So that's why we say that is force along the x-axis is equal to 0. Force is equal to mass into action along x-axis. Mass is not equal to 0. So it means acceleration along x-axis is equal to 0. It means the velocity component u cos theta, that will remain same along the x-axis. This will not change because there is no force along the x-axis, there is no acceleration along the x-axis. And if we intend to apply equations of kinematics like v is equal to u plus at, final velocity is equal to initial velocity plus x into time, and we write it over here as x, so that we are not confused with the x components and y components. So vx is equal to ux plus ax is equal to 0, ax is equal to 0, so 0 into t, so vx is equal to ux, that is a velocity along the x-axis. It remains as u cos theta only, that is initial velocity along the x-axis, it is u cos theta. So all the time this component of velocity along the x-axis will always remain as u cos theta. To understand it further, let's say light has been projected from here. It's a rectilinear propagation of light. Light has been projected from here and a stone has been thrown like this. So stone goes like this. When the stone is here, the shadow will be here. When the stone is like over here, then shadow is here. When the stone is here, shadow is here. When the whole incident is taking place, when the body is going from here to here, certainly the shadow shall be moving in this direction. What do we mean? That is acceleration along the x-axis is equal to 0, or the velocity along the x-axis remains same. It means that is when the stone goes from here to here, this shadow onto this ground shall be moving with a constant velocity, that is u cos theta. So when the body goes from here to here and the light is projected from the top, the shadow on this ground shall be moving with a constant velocity without any accident, that is acceleration along the x is equal to 0, and it shall be moving with a constant velocity onto the ground with the value u cos theta, and there will not be any change in this velocity. And if we are interested, that is how this shadow shall be moving on the y-axis, for that what we do is, once again we take this as x-axis, we take this as y-axis, this is u at angle theta, we break it into two components. One is u cos theta and this component is u sin theta. It takes this path. Now let's say we insert light in this direction. So when this stone or body is over here, the shadow is here onto this screen. When it is over here, the shadow is here. When it is at topmost position, shadow is cast over here. When it is over here, the shadow is here. When it is here, shadow is here. When it is here, shadow is here. So when the body goes from here to here, the shadow goes like this. It goes up, comes down. So this is also like motion in one dimension only. We see that its velocity shall be changing. Over here it's maximum, and gradually it is reducing, and at the topmost position the velocity over here it comes out to be equal to 0. Then it starts a backward journey and the velocity starts increasing in the downward direction, and over here it is increasing, and over here it is maximum. At the maximum height over here the velocity is equal to 0. It means the velocity component over here Vy, that is going to be equal to 0 at the topmost position. We are not saying over here that is the net velocity is equal to 0, because the x velocity, x component velocity will remain as u cos theta only. Now so far what we have done is, we have broken the velocity along the x-axis and along the y-axis. Let's say this is x-axis, this is y-axis, this is velocity u with which it has been projected in this direction at angle theta. This goes like this. We have broken this velocity in two components. One is u cos theta, which is responsible for its motion on the x-axis, and this is u sin theta. this is the initial velocity component on the y-axis, which shall be responsible for its motion on the y-axis. Apart from this, we know that is all the time when it is going from here to here, acceleration along x-axis is equal to 0 because there is no force along the x-axis. So that's why acceleration on the x-axis is equal to 0. And all the time when the body is going from here to here, there is a force along the y-axis which is equal to mg in the downward direction. Force is equal to mass into acceleration, that is net force is equal to mass into acceleration. So along the y-axis, if we say the force is equal to m into g in the downward direction, so force is equal to mass into acceleration. So it means we can say ay is equal to g in the downward direction. So now we have ax is equal to 0 as one thing. Also ay is equal to g in the downward direction. This is the other thing we should remember. Apart from this, we also remember that is velocity is always tangent to the path. Velocity over here is tangent to the path, velocity over here is tangent to the path, velocity over here is tangent to the path. And when the body is at the topmost position over here, it has two components. U cos theta will always remain same. That is the x component. There will not be any change in the x component because acceleration on x-axis is equal to 0. It means this component will always remain same whatsoever the velocity of the body. This component will always remain same, u cos theta, u cos theta, u cos theta. Over here also u cos theta. All the time x component will not be changing. The only change will be only in the y-axis component. That is, this y component will be changing. Over here it is this much, then over here it reduces, and over here at this position the vy component comes out to be equal to 0. So once we have done it, then the rest of things, they are much easier because now we have to just use equations of kinematics with sign convention, and we can get the time of flight, we can find what is the maximum height, and we can also find what is the range of this projectile. Like if you have to find the time of flight, that is time from A to B, it takes, we have to find that. This is a scalar quantity. So what we say is we use the equation Sy is equal to Uyt plus half Ayt square. Let's use this and see how we can apply this equation of kinematics to find the time of flight of this projectile. Sy, displacement on the y-axis. What is the displacement on the y-axis? Displacement on the y-axis is 0 because the level of this and level of this, the y coordinate of for both of them, it is same. We are not just bothered what is happening on the x-axis. Whether the body has gone forward or in the backward direction, we are not bothered. We are just bothered what is the distance between these two levels. And these 2 points, this A and B, they are the same level. So displacement along the y-axis, that is going to be equal to 0. So we say it is equal to 0. Uy, initial velocity along the y-axis, you have to remember we are taking the vectors in the upward direction as positive, the downward direction we are taking as negative. Uy, initial velocity along y-axis, where at point A, initial velocity is at the initial point A, at A, along y-axis, this much, it is u sin theta. It is in the upward direction or downward direction? It is in the upward direction. In the upward direction, it has to be taken as positive. So it is plus u sin theta into t plus half. Ay is g in the downward direction. G in the downward direction is negative. So it is minus g into t square. So this comes out to be minus u sin theta t is equal to minus half gt square. T is not equal to 0, so that's why this t and square get cancelled, minus minus. So it comes out to be, t comes out to be 2u sin theta by g. So this is the value of time of flight from A to B. Please note that this time of flight is only when this initial point and the final point, they are at the same level. If the body has been projected from a tower where the initial level and the final level, they are not at the same level, that is Sy is not equal to 0, then it is going to have some value, and accordingly the value of time of flight will change, and you cannot use this formula directly, that is time of flight is 2u sin theta by g. This time t is equal to 2u sin theta by g is applicable only when the point of projection and point of receiving, they are at the same level.